Good morning, boys and girls. Yesterday there was again an uploading problem, and I had to put the lecture very late in the evening. It was almost 10:30 or so, I believe. Boys and girls, it is a good morning to you all today, and I'm sure you will have a lecture on time today. And please see that you keep on asking your doubts. It was a very interesting discussion by you all. And I hope you got the differential and integral part. But at this moment of time, we are just leaving the differential and integral and have moved into a new lesson called units and measurement. And there's something which I introduced, which is called dimension. The concept of differentiation and integration will be taken up in the next lesson. It's going to be there. We're going to study the entire subject of the differential and integration. All those students who are joining now will first do the lectures which I am doing now. They will completely follow it. And side by side, they can do their differentiation and integration also and keep asking me your doubts. Yesterday, we wrote down the units in the international system. The international system is a coherent system of units. The international system of units contains quantities and its units, by the multiplication and division of which we are able to determine the units of any physical quantity in the subject. For mechanics, mass, length and time are sufficient. And we introduce and one of the units of SI. Praneet talked to me in detail about that. Anybody is welcome. Whosoever will chat with me or talk to me, it is even Jashanpreet asks a lot. Anybody, it's a pleasure. It's a pleasure. When you ask something, it means your mind is really working. Please keep asking. The important thing is to never stop questioning. I'm sure students who have been asking me and you've been helping each other also. That's also wonderful, really wonderful. It gives you such a good feeling when somebody says, okay, samajh aa gaya yaar. You know, and please keep helping each other and you can keep asking me also. The unit of angle, there are 7 basic quantities and 2 subsidiary quantities. The 2 subsidiary quantities are angle, and the unit of angle is radian. Especially this would be a problem with medical students. Like an angle is always in the anti-clockwise sense. This is the angle. This is 30 degrees. You all know it is degrees. And if the line is here, OP is here, and this angle would be 90 degrees. And if it is, the line is here, then this angle would be 180 degrees. Right? We say this angle is pi radians. This is pi by 2 radians. This is pi radians. It is just a conversion. Thus, pi radians is the same thing as 180 degrees. And 2 pi radians would be the same thing as 360 degrees. This is 2 pi radians. This complete angle would be 2 pi radians. Thus, 30 degrees. If pi radians is 180 degrees, 180 degrees is pi radians. Therefore, 30 degrees would be pi by 180 into 30. Pi by 6 radians. Okay, Praneet, I promise Praneet that it will be the first thing that I do in the lecture. Whenever you will ask me something, if it is minor and it seems that it is on an individual, it seems that it is of an individual nature, I will explain it to you there and then. If I find that it could be better for the class, you know, a doubt is something very, very important. And when you discuss a doubt, sometimes I will feel that this should be discussed in the entire class. So let's keep helping everyone. I hope anything is clear. Pi radians is 180 degrees. Okay. Then we started with fundamental quantities, derived quantities, fundamental units, and derived units. Basic quantities or fundamental quantities are those quantities which cannot be derived from each other. They cannot be expressed in terms of other quantities. In mechanics, we have mass, length, time, and for the entire subject, we have the International System of Units. All quantities in the International System of Units cannot be expressed in terms of each other. And their units are called fundamental or basic units. There are certain quantities, all other quantities, speed, momentum, force, impulse, magnetic field, electric field, charge, and any quantity you name, that can be written in terms of basic quantities. Their units are called derived units because they can be derived from the units of basic quantities. Meter per second, it is the derived unit. Newton, yesterday I also explained, it is not Newton, it is kg meter per second square. We call it Newton. And so on. Joule, it is 1 Newton into 1 meter. Kg meter square upon second square. And then we call something as dimension. Fundamentally, anything that is mass would be written as capital M in square brackets. Anything that is length is written as capital L in square brackets, and so on. It is very important. Dimension. Like we have, I gave you this example yesterday also. Okay, now it's a different example. Work. Work is force into distance, force into distance. Force is mass into acceleration into distance. This is m, this we remember as lt minus 2, and distance is again m. This is work. Yesterday I explained to you that this power, m to the power 1, n to the power 2, t to the power minus 2, the power is called dimension. The power is called dimension. ml to t minus 2 is called dimensional formula for work. And W is equal to ml to t minus 2 is called dimensional equation. I hope I can start. Let me divide various quantities into constants and variables. Variables and constants. Boys and girls, as I keep on writing on the board and speaking, you can also write sideways, just as you do in a real classroom. We will have something called dimensional variable. Those quantities which have dimensions and can have a variable value. Quantities having dimensions. You can say, sir, won't all quantities have dimensions? No. I will just give you an example. Quantities having dimensions and can have a variable value. Boys and girls, I will not rush into MCQs. I don't have to prove anything to you. I know what I am doing and what is required to be done. I will always go from the basics and start very slowly. I'm like a test cricketer, Even if it is a 50 over match, we need to watch the ball in the first initial overs. बाद में कुछ भी कर सकते हैं. So I will go very slowly initially and then we'll pick up speed and ultimately we'll finish much before. Quantities having dimensions and can have a variable value. Examples? Anything, Mass, length, time, कुछ भी हो, speed, velocity, speed, momentum, speed, distance, force, etc. A particle can have any speed. Distance could be 5 meters, 8 meters, 100 meters, kilometers, even light years. Dimensional constants. Please define it on your own. I won't write it, but you will write it in your notes. Dimensional variable was quantities having dimensions and can have a variable value. Dimensional constant क्या होगा? Quantities having dimensions but have a constant value. Okay, लिख देता हूँ. Quantities having dimensions and have a constant value. Example, gravitational constant. Gravitational constant can be expressed in terms of mass, length and time, but its value will be fixed, universal. Planck's constant, etc. There can be so many. Non-dimensional constant. Non-dimensional constant. Those quantities, no, I'm not going to write it now. Those quantities which do not have dimensions but have a constant value. You know, do not have dimensions and have a constant value. Example is obvious. Any number, 3, half, 22/7 and so on. Any number. You do not need to express a number in terms of mass, length and time, and its value is obviously fixed. The last one would be non-dimensional variable. Non-dimensional variable. By non-dimensional variable we mean those quantities which do not have dimensions but can have a variable value. लिख लेना. Those quantities which do not have dimensions but have a variable value. So we can have dimensional variables, dimensional constants. We can have non-dimensional constants and non-dimensional variables. Example of non-dimensional variable. Okay. Angle. Very nice. Something which is a pure ratio. Something with a pure ratio. How is angle a ratio? Angle is arc over radius. Arc length, you know, is like this. This is angle. This is the length of the arc. And this is the radius. This is the length of the arc now. Theta is L by R. So this is dimensions of length upon length. Would be dimensions M0, L0, T0. We call it dimensionless. And we can have any value. Pi radians, pi by 2 radians, 2 pi radians, 30 degree. You know, it's a beautiful thing. We will use these constants and variables in calculating the dimensions of variable quantities, and you will enjoy your work for sure. It's very simple, but just be careful, you know. Now, we will list. Okay, just an interesting question. Interesting question. Whenever I ask an interesting question, it's always like this. If a quantity has a unit, Will it surely have a dimension? If a quantity has a unit, will it surely have a dimension? It's like plain true false, you know. Another statement is, if a quantity has a dimension, will it surely have a unit? Both are very interesting statements, you know. If a quantity has a unit, okay, you can think about it. Okay, one of the statements is true and the other is false. Okay, had it been a class, we would have really enjoyed ourselves. You know? Okay. If a quantity has a dimension, if you have written something as MLT, whatever, instead of mass you can write kg, length you can write meter, time you can write second, MLT minus 2, kg meter second minus 2. It is sure that this is a true statement. This is a true statement. But this is a false statement. Why? Just now we did angle. That is where it struck me, you know. If a quantity has a unit, angle has a unit, degrees, radians, but it does not have a dimension. There could be more examples also, but at this time you would follow this one only. More about such things. Such questions are the heart of the subject and they make you think, and we have to build a character. We have to build a scientific temper so that we begin to think like this, and it is always by such critical questions that we will enjoy the subject. Hope you have understood it, that if a quantity has a unit, it is not necessary that it will have a dimension. I asked the question in a different manner. Will it surely have a dimension? No. There are quantities which have units as well as dimensions. But if a quantity has a unit, it is not necessary that it will have a dimension. It can have, but it is not necessary. But if a quantity has a dimension, then it will surely have a unit. Hope you understand. Let us start our discussion. Let us start our discussion on how to calculate the dimensions. Now, today I'm going to scan some quantities and ask you to find it. Let me start initially. Hope the video is working, you know. Okay, we're just 18 minutes into the lecture. To know the dimensions, you should know the formula. There are certain quantities which you have studied, but I will teach you to calculate the dimensions of those quantities also, which we are going to study in the next 2 years. Don't bother about the quantity now. That is why most teachers will not do this lesson. But I know once we skip a lesson, we cannot come back to it. And I have students coming to me in the next year in +2, sir, we have not done this, we have not done this. Please see that we cover things properly. I've been teaching for more than 25 years, you know. Now, I repeat, there would be certain quantities which you do not know. Surface tension. We will study surface tension in detail when it comes. What I am going to teach you now is that if you know the formula, then you should know how to calculate the dimensions. The dimensional formula. The first quantity, I start with very simple, let's say volume. The formula for volume is length into breadth into height. Therefore, you will write the dimension as L cube. Right? Anything that has the units of meter would be written as L. So L is 3 times. Okay. Speed. The right, as you know, is distance over time. Thus the formula would be LT minus 1. This is the dimensional formula. Okay, acceleration. It is speed over time. Student would say it is change in speed over time. Okay. Look, dimensionally length plus length would be length. 5 meters plus 3 meters, 8 meters. It is from the meter where it is coming. So dimensionally length plus length is length, not twice of length. Length minus length would also be length. Right? Speed is LT minus 1 over T. And the result would be LT minus 2. The more you keep this in mind, speed, distance over time, LT minus 1. Acceleration, speed over time. Speed is distance over time. So speed is LT minus 1, that is T minus LT minus 2. If we remember these, it would be very convenient. Force. Force is mass into acceleration. Straight away, mass LT minus 2. You could also express it, acceleration as speed over time, and speed is length over time, but there is no need. Okay, now, momentum. Linear momentum. Because there is something called angular momentum also. Linear momentum. The symbol is P and the formula is M into V. LT minus 1. Today's work at hand to you will be to calculate the dimensions of so many quantities which I will give you, but I will give you the formula. You have to learn to calculate the dimensions. Okay. Angular momentum. You do not know what angular momentum is. Don't bother at the moment. It's an entire chapter. But the formula is mvr. When you will do this, you will automatically also remember it. At the moment, those terms which you have not done, which you do not know, I will tell you the formula. What my aim is you should be able to calculate the dimensional formula if you know the formula. V speed LT minus 1, R is distance L. Thus it is ML2 T minus 1. It's very easy once you get the flow. Okay. Kinetic energy, let's say. You all know kinetic energy is half mv square. Right? Half. There is no need to write half. No need to write 0 also. Write nothing. We don't write anything. It is a non-dimensional constant. Just forget it. Mass is m. And speed is LT minus 1 ka square, resulting in ML2 T minus 2. Okay, let me calculate gravitational potential energy, which you all know as mgh. Right? Please do it yourself. M is mass. What is g? You will say g is a constant. G is not a constant. It varies. The acceleration due to gravity varies for different locations in space. Now, what would be the dimensional formula for acceleration to gravity? जनाब है तो acceleration, चाहे gravity की हो, चाहे कार की हो, चाहे घोड़े की हो, चाहे गधे की हो, है तो acceleration. Anything which is acceleration, बस की, आपकी, kinetic की, its units will be that of acceleration, which will be LT minus 2. H, distance, L, giving me ML to T minus 2. It is the same. It means two different quantities can have the same dimensional formula. है तो energy. Even if we calculate electrical energy by some other formula, it has to be ml T minus 2 because it is energy. This is the beauty of the subject. Magnetostatic potential energy, electrostatic potential energy, kinetic energy, है तो energy. The dimensional formula from any result will always come out to be ml T minus 2. This is the beauty of the subject. Okay, another one. Let's move a step forward now. Okay. I want to know the dimensional formula for a gravitational constant. And its symbol is capital G. You must have heard of the result that F is equal to G m1 m2 over r square. If you have not, we will do it in detail. Whenever you are asked to determine the dimensional formula for some quantity, that quantity should occur in some formula. And you can calculate the gravitational constant will occur in so many formulae. You can calculate the dimensional formula of gravitational constant from any quantity. The most convenient is, as F is G, whose dimensions we have to find, m1 m2 over r square. 1 and 2 are not dimensions here. They are simply two different masses. And r is the distance between them. R is the separation between them. You will keep on one side the dimensions whose quantity, the quantity whose dimensions are to be found. First of all, you should identify a result which contains gravitational constant. There could be so many results. Then keep G on one side. F, force. Mass into acceleration. M, LT minus 2. M, LT minus 2. R, distance. M1, mass. Another mass. M2. Thus, the dimensional formula for a gravitational constant is M minus 1, 1 minus 2. This is L3, that is T minus 2. Some students ask me, so do we have to remember them? No. कितने की याद कर लोगे? You will always have to work them out. If unconsciously you remember it, okay. Never try to remember a dimensional formula. Derive it. It takes just a few seconds. Okay, another frequency. Frequency is 1 by time. Thus its dimension is T minus 1. Let me have another one. Planck's constant. Planck's constant is actually H. And H occurs in E is equal to H nu. Nu. E is energy. H is the Planck's constant. I'm doing it here. Thus, H is energy over frequency. Energy. If you remember energy, it's okay. If you do not, energy is work. Force into distance. Energy is work. Force into distance. Force is ml t minus 2 into L. ml to t minus 2. ml to t minus. Or from our v square, also you can work it out. The dimensional energy work will be the same. Frequency is 1 over time. T minus 1. Thus, Planck's constant has dimensions of ml to t minus 1. Is there anything else on the board having the same dimensions? Yes. Angular momentum, ml to t minus 1. Planck's constant, ml to t minus 1. This means that two different quantities can have the same dimensional formula. Two different physical quantities can have the same dimensional formula. Is the reverse true? Is the reverse true? Think. The reverse is, can one physical quantity have two-dimensional formula? No. Can two physical quantities have the same dimensional formula? Yes. I am telling you, you will enjoy this subject. But you have to start thinking critically. I will keep on asking you questions as we keep on moving into lectures. The next day, the subject is going to be very interesting. We'll make it interesting. God damn interesting. Yeah? So you can write this thing down that two quantities, two different quantities can have the same dimensional formula. Example, work and energy, angular momentum, Planck's constant, and then, but a single physical quantity cannot have two-dimensional formula. Now, today's work will be only to calculate the dimensional formula for various quantities. I'm still into mechanics only, you know. Switching off the air conditioner. Sorry. Let me introduce certain quantities which will take us outside mechanics. The first is charge, let's say. Charge is not fundamental. Current is fundamental. It means charge has to be expressed in terms of current and time, and not the reverse. Charge. The formula for charge is Q is I into T. Thus the dimensional formula is I T. Right? You can put an arrow here. Equal to it is really bad. Okay. It's a beautiful expression now. Permittivity. Okay, electrical permittivity. Yeah? Electrical permittivity. I'm doing it with plus 2 these days. Even if you ask me now, what are the dimensions of permittivity? I don't remember. We will have to calculate it. The symbol is epsilon. Just put a curve, let's put a C and put a line in between. It's not an E, it's epsilon. We have an expression F is equal to 1 over 4 pi epsilon Q1 Q2 over R square. Q1 and Q2 are both charges. The two charges, 1 and 2 are not powers. Powers dimensions होती हैं. Q1 is one charge, Q2 is another charge. Both will have dimensions of charge. We have to find the dimensions of epsilon. 1 over 4 pi F into Q1 Q2 by R square. This will lead to, or you can simply write dimensions here. 1 over 4 pi. 1 over 4 pi is a non-dimensional constant. And force will have dimensions of mLT minus 2. Q1 will be IT, and that is twice, because there are two charges. R, distance, L2. Let us simplify this. M minus 1. I hope you are getting it. In the denominator we have L3. Thus, when we take it up, it will be L minus 3, and we will have T4. This is the dimensional formula for permittivity. M minus 1, L minus 3, T4. We're still left with I. We're still left with I. And I2. You can write A also. Instead of I, you can write A also. We can have so many quantities. We just have to know one of the results. Okay, stress. You've not heard of this quantity, but I will tell you the formula. Force over area. Force is mLT minus 2, area is L2. The answer is mL minus 1, T minus 2. Okay, strain. Strain is change in length upon original length. You stretch a wire, its initial length is 2 meters, its final length is 3 meters. Change in length is 1 meter. है तो meter? Thus, length or change in length will have the dimensions of length. Original length, है तो length L. Dimensionless. Boys and girls, that is all for today. I will give you will do these quantities yourself. I hope you have already written them. And today I will give you at least 15 to 20 quantities with results. There would be some results which you have done. There would be some which we will do in the coming 2 years. But for today, we are going to learn how to calculate the dimensional formula for various quantities. Just isolate that quantity and write it in other terms and then write its dimensional formula. Have a good day. We've got almost 2 lectures to work it out. Yesterday's and today. Please ask me your doubts. It is most important for me. Thank you.